Hello, my name is Jereck Borne, and I am the Field Safety Technician for our company. Today, I will be presenting on the dose-response relationship using benzene as a workplace hazard. We'll go over how exposure affects the body, the risk involved, and the exposure limits used to protect workers. In this presentation, I will explain what benzene is and where it is commonly found. I will also cover how workers are exposed, how it affects the body, and the dose-response relationship. Finally, I will go over exposure limits and how we can protect workers from harm. Benzene is a colorless or light yellow liquid with a sweet smell and is highly flammable. It is commonly found in crude oil, gasoline, and cigarette smoke. It is also widely used in industry to make products such as plastics, resins, nylon, and detergents. Workers are most likely to be exposed to benzene in industries like refineries, gas stations, and chemical plants. Environmental exposure can also occur from vehicle exhaust or hazardous waste sites. The primary route of exposure is inhalation, but benzene can also enter through the skin or by ingestion. Benzene affects the body by disrupting normal cell function. It targets the bone marrow, which is responsible for producing blood cells. This can reduce red blood cells, causing anemia, and weaken the immune system. The dose-response relationship shows how the level of exposure affects the severity of health effects. At low levels, there may be little to no symptoms. At moderate levels, changes in blood can occur. At high levels, exposure can lead to severe illness or even death. Long-term exposure significantly increases the risk of cancer, especially leukemia. In the short term, benzene exposure can cause dizziness, headaches, confusion, and irregular heartbeat. Long-term exposure is much more serious and can lead to bone marrow damage, anemia, and cancer. It may also affect reproductive health. To protect workers, organizations set exposure limits based on research. The ACGIH-TLV is 0.5 parts per million over an 8-hour workday. OSHA's legally enforceable PEL is 1 part per million. NIOSH recommends an even lower limit of 0.1 parts per million. These limits are designed to reduce the risk of long-term health effects. To reduce exposure, we use engineering controls like ventilation, along with personal protective equipment such as gloves and respirators. Air monitoring and worker training are also important. If exposure occurs, the workers should move to fresh air immediately, remove contaminated clothing, wash thoroughly, and seek medical attention. In conclusion, benzene is a serious workplace hazard, and understanding the dose-response relationship helps us recognize the risk. Exposure limits are in place to protect workers, but proper controls and training are essential. As a field safety technician, it is important to communicate this information clearly across all job sites. Thank you for your time. Now I'm happy to answer any questions.